Hello and welcome. I am Alexei Villas-Boas. I'm the head of tech for ThoughtWorks Brazil, and I will be your host for this webinar this time. And this is the sneak peek webinar for the Tech Radar Volume 20. It's wonderful to have you all here with us, so thank you so much for joining. And we also have Jean-Marc and Sudarshan to take us through this preview of Volume 20 this time. Hello, Jean-Marc. Could you please introduce yourself?
Sure. Hi, everyone. I'm Jean-Marc Dervani. I'm one of the principal consultants at ThoughtWorks. I'm based in San Francisco and joining you for this webinar at 7 a.m. So I just woke up. So I'm warming up. Excited to be here.
Thank you so much for joining so early, Jean-Marc. I guess that's the price we paid for having a global team, right? So some people are always going to need to be awake at uncomfortable times. And hello, Sudarshan. Could you tell us a little bit about yourself and where you're speaking from? By the way, I'm speaking from São Paulo, so it's not early for me. It's
Yes. Sure, Alexei. Hello, everyone. My name is Sudarshan. I'm a tech principal from ThoughtWorks, and I'm speaking from Bangalore. It is not very early for me. It's in fact quite late in the day. And as you say, the global setup.
Thank you very much. And well, we're here to talk about some of the themes and blips that will come out on the next Tech Radar. It should be out quite soon. And well, for those of you not familiar with the radar, twice every year, we gather some of our most senior technologists to talk about, well, the things we're using in our projects, in our clients. ThoughtWorks is a global company, so that inevitably will lead us to discussions that will include context, well, across tech stacks, across industries, and also around the globe. The radar looks at tech blips related to techniques, platforms, tools, and languages and frameworks. And then we categorize them into 4 rings. And just a brief overview of what that means. So, from the middle outwards, the adopt ring will contain blips we feel strongly the industry should pursue. So those are things that we use in our projects whenever appropriate, and things we feel are, well, mature for use. The second one is trial, and something in trial, something we feel is worth experimenting with. So they're not blips as mature as the ones in adopt. So using them in environments that can handle the risk might be more appropriate. And then comes the assess rings. And those are things we feel we should keep an eye on. So they are things that might be worth exploring. And finally, we have the hold ring. And that one is for things we feel people should proceed with caution. So it contains things that, well, generally we haven't had a good experience with. I should also say that the radar is future focused. So we need to fade blips to make more room for new ones. So the faded ones, faded blip doesn't necessarily mean that it's not relevant anymore or it's not important, but well, we need to make room for the new things. I would like to ask everyone to feel free to post questions as we go. You should be able to see a Q&A button mid and towards the bottom of the window. There's also a chat room. Feel free to use the chat room for conversation, but it's going to be hard to monitor the chat window for questions. So please prefer the Q&A button to post questions if you can. And now, without further delay, let's see what this new edition brings us. So Jean-Marc, what's caught your attention on this new edition?
Sure. So I have picked some of my favorite clips. Some are new, some have changed. Starting with the first one, which is a technique called continuous delivery for machine learning. It's a relatively new technique, and we've been kind of playing with it, applying it at different kind of client contexts, and it's sitting on that assess ring. If you think about machine learning modeling and delivery, traditionally teams kind of face 2 main problems. So one problem is the long cycle time between training models and deploying them to production, so that they can be using operational systems and produce automated decisions or automated actions. And often this long cycle time between training and deploying to production includes a bunch of manual work, like data scientists handing over their models to data engineers, and the engineers writing the models in languages and frameworks that are suitable for kind of building long-running production code. That's one of the first problems. The second problem is the long cycle time after deploying to machine learning. So if you're one of those lucky ones that actually get their machine learning into production, the cycle time between that and retraining your model based on the fresh data that's coming to the system. And in fact, what we find is that a lot of machine learning models continue to operate in production on stale data, where the data that's been trained on no longer represents a distribution of the real data that's coming and hitting those kind of machine learning systems for results. So what continuous delivery is trying to do is a technique that it attempts to address these two problems. Basically applies CI/CD practices to machine learning model development, so that you have the tooling and the pipeline in place that you can continuously train, test, deploy to production, observe, refresh new data, and retrain your models and continue the cycle. And like any other machine learning continuous delivery application, there is a pipeline in place to enable all those steps, ideally automatically. And if you think about a normal application continuous delivery pipeline, there are always triggers, right? The triggers for a normal application is usually the source code change. So source code changes, it's been checked into some sort of source code version control, and that triggers the machine. And that's true for machine learning as well, machine learning based, I guess, applications. If the model structure changes, that would result in triggering the pipeline. Essentially, your code has changed. And also, if your training and test data sets changes, if you're getting fresh data and hopefully you have some sort of a real time and fast delivery of the data sets that you can train your models as well into the system, changes to your data sets also impacts your machine learning configuration, so that would trigger another cycle of test and deployment. And when you think about it, the underlying construct that you would need to have in place for these triggers to work is some sort of a version control system. You need to be able to version control your machine learning as well as version control your data sets. And that's kind of tricky as well. When we think about data sets, we think about this massive kind of amounts of data and how we're going to go about versioning it, and that's a tricky problem. But we've had tools in our previous radar that tries to address that problem. One of them is DBC, which is an open source control system for machine learning projects. It sits on top of Git, and it also connects to different storage for your data on the cloud, such as S3 or GCP or other cloud providers. And it provides a Git-based kind of Git-like flow for your machine learning data sets and models. And even using these tools, we kind of implement the premise of machine learning, premise of continuous delivery, which is reproducibility, right? In this particular case, reproducibility of your analytics. And if you think about, a typical continuous delivery pipeline has been something that we've been trying with our clients. It's a very popular topic. There's a lot of room for improvement here, but we've been basically using our GoCD, which is an open source CI/CD engine to implement to kind of configure the pipelines, and you will have steps for testing. You'll have steps possibly even for automatic conversion of your models. Like ideally, the data scientists have the right tools and have the right kind of frameworks and languages to even required to convert their models from one language to another. But if they need to, we've been using frameworks like H2O, which is already on the radar as well, to kind of convert models to Java jars to be deployed, and monitoring in place to deliver value. I think that we have a counter, I guess, link to this, which is a glip we call productionizing Jupyter notebooks, and you will see that on the upcoming radar, which you can think about in the context of continuous delivery for machine learning, which is a trend we're observing. People are applying to enable data scientists who are using Jupyter notebooks for their day-to-day exploration or sharing their models or reporting to be able to deploy those to production. And why we think it's a noble act to enable our, kind of citizen data scientists, we also caution, I guess it's one of those things that we caution our clients against, which just because Jupyter notebooks, they haven't been designed to be running as long-lived, maintainable, extensible framework for production-ready code. It's one thing to deploy them for exploration purposes in the production, and the other thing to actually have them as a long-running medium or source code, essentially, for other data scientists to come in and extend it and change it. There are some concerns about error handling, separation of concerns, the modularity, with all those things that you need in a kind of programming language to kind of evolve it over time. So we would encourage you to put your energy into building continuous delivery, putting adequate tests in place for model deployment to production.
Yeah, sure. It's going to continue to production, but with all the quality and the ceremonies and the checks that we need, right? So it's great. Wonderful. Thank you so much, Mark. And how about you, Sudarshan? What's caught your attention on this edition?
One of the things that caught my attention was a relatively new time series database called Timescale DB. So this is interesting because lately we have been seeing in our projects increasingly that time series databases are showing up, perhaps more than they used to in the past. Like I don't remember seeing as many of them, let's say 2-3 years ago, but now I feel like a lot of projects I'm encountering seem to have a time series database in them. Of course, one of the main reasons is the importance of that most projects are giving to monitoring, and time series databases are at the heart of most monitoring systems. But there are a lot of domains where time series databases seem to be a natural fit as well. Some good examples being, let's say you're in the logistics industry, containers and shipping, for example, and if the containers are constantly providing data about their movements and stuff, that naturally fits the time series domain. And similarly for the IoT domain as well, like there's a lot of data flowing in, and it's very naturally an IoT, a time series data. Now, Timescale DB, their wonder to happened relatively recently, around 6 months ago or so, is one of the newer entrants. And what's interesting about Timescale DB and what caught my attention is they actually built it on top of Postgres. And that seemed like a curious choice. Like Postgres is not known to, scale for the sort of time series data that you need to scale to. And in fact, experiments do show that it can't handle ingest at the rate of, hundreds of thousands per second once the data size grows beyond a few hundred million. So, it was curious to me that the Timescale DB chose Postgres, and they have some very, very good reasons to do that. So how do they actually make it scale? How do they actually use Postgres itself? And they basically very cleverly used some of the properties of time series data. And time series data have some properties, like, for example, it's insert only. You don't have to go and append. You're not going to go and delete. And it's an append only sort of data. Another interesting property of time series data is it's partition on time. Like you don't need to keep all your indices of your entire data set in memory. You just need to keep indices of your newer partitions, if you will, in memory. So using some of these attributes, they basically engineered on top of Postgres. They introduced a concept called hypertable that they're calling hypertable, which is essentially an abstraction on top of normal Postgres tables, just partitioned. So you partition across time and some of the dimensions of the data itself. And using this, they managed to get a very, very high ingest rate. It also, apart from the massive ingest rate, they also have done some optimizations for the querying, because time series data often you query based on time windows, and that means you only query on some partitions. You don't need to worry about the full data set. So all of these are, what they did on top of Postgres. But this is what makes it really interesting. A time series database, but where you can use SQL, because it's on Postgres. It's just tables. So which means you can just open up your normal Postgres client and start writing SQL and get most of your answers done. And they can do joins. They can do secondary indices. These are stuff which you don't normally get in either a time series database or in NoSQL databases in general. So that's a very interesting choice. I think some time ago, I don't remember when, but I believe there was a previous Radar where we talked about Postgres almost as a meta database to build other databases on top of. And this is, I think, a perfect example of that. Of course, there are some things to watch out for. Timescale DB doesn't yet support clustering. It's in development. But I imagine it's not too far away, because given their whole partitioning scheme, they already have all the primitives for clustering. So I expect we'll see that shortly. It's definitely one of those interesting databases. And I think definitely
Cool.
worth keeping.
Thank you so much. Well, so far 2 bleeps related to data. I wonder if there's a theme around that, but anyway, I think it's still too early on in the webinar to tell. Now, I do see Istio on the slide, and well, ThoughtWorks has been advocating for microservices for a while, and I know our teams have been feeling quite excited about advances in service meshes. So is that right, Jamak? Jamak, you're on mute. Sorry.
Oh, sorry.
Okay,
yes.
now I can hear you.
Yes. I'm super excited about Istio, so I'm going to talk about that. But thank you for a couple of keen observers in the audience. We had some stuff, the assess and trial, Timescale DB, and live update that Gareth probably did. The Timescale DB is on assess and Istio on trial. So Istio is actually not new to our radar. It's been on our radar since last year. It was actually one of the highlights of my life in 2017 when service mesh got quite popularized with Istio, and I've been a strong advocate of that. And this time around, we're very cautious about moving technologies that we are using in maybe 1 or 2 places, and we are trying, and we're not quite sure how it's going to work. And moving that to trial. Trial is fairly a strong embracing of the technology to say this is a good chance we have had good experiences, and that's what happened, I guess, on this radar. Given the feedback of our engineering teams, we feel safe to say Istio is on trial and it's a good choice. So for people who are not familiar or new to Istio is an open source implementation of the service mesh. And Google, Lyft, who implemented the Envoy sidecar, and IBM have been heavily contributing to that. And service mesh, just briefly describing what service mesh is. Service mesh is an approach to kind of operating a microservices ecosystem. How to securely and reliably and in a fast way we can build a network of microservices systems. And service mesh, and particularly Istio, implements a few cross-cutting concerns that really accelerate our teams when they are building or operating and simply scaling a microservices installation. It implements a bunch of cross-cutting concerns. It implements kind of things that you need to implement to support resiliency. So in a microservices ecosystem, systems can go up and down, and you don't want to be able to, you want to control the radius of the impact of that failure. So Istio implements retries and a few other things to implement resiliency. It implements observability out of the box, so you can capture traces for inbound and outbound calls to your services. It uses open tracing kind of model, framework or standard. You get metrics kind of out of the box, error rates, response times, and so on. And it implements a bunch of routing policies. So one of the other, kind of main challenges with microservices is that, you have this distributed system and multiple, that at any point in time, you might have multiple versions of your microservices. So how do you route requests from to one version versus another? You may want to do A/B testing to see which service, maybe this is kind of in the backend side, how different implementation of the service might be responding. Or you have canary releases and deployments of your services, so you can move traffic from the old version to the new one, and you have the old version. So these kind of routing policies are built in, and one feature that kind of makes me most excited and kind of want to use Istio or service mesh kind of on my microservices projects is security. The nature of how we implement security in a distributed microservices is very different to how we've done security in kind of monolithic applications. So we actually have a blip on the radar from the previous revisions, which says security in the endpoint, which basically is about implementing all security concerns, authorization, authentication, kind of encryption right at the service. So you don't need to worry about in your network to having a fault agent in a way. And you assume that you're operating in a zero trust network. So all the traffic between the two services, there's a virtual TLS between the two that use both for identifying your workloads for your services. And I call this other service is a reliable encrypting the traffic with mutual TLS, as well as putting policies around what service can I call, or who can call me, and what sort of access control at the level of every APIs I might want to put on that service. So these are super exciting. There's another belief actually related to this that moved again, SPIFFE, S-P-I-F-F-E, which is a standardization around the extension to TLS to kind of uniformly identify your workloads or your services. So identity, so implementing a strong identity, and that's a standard that's been adopted as part of the Sandbox CNCF Cloud Native Computing Foundation projects. And both Istio and also other implementations of the TLS service are using it. And what's, I think, I'm going to ruin actually Alex's question around this that he mentioned to me. I'm going to kind of maybe answer that a little bit right now. But when you think about microservices, there's a headache that goes with implementing it. And one of these is, okay, we know that we need to provide all of these cost-cutting concerns and implementing one way or another. And typically the implementation of these have been through libraries, we call them service chassis or templates within each service. And the headache that goes with that is continuously trying to keep these libraries in sync and up to date, because we talk about autonomous things that are running around doing their own thing, and then how do you make sure that they are upgrading their services and deploying them with new versions of these libraries that implements resiliency and security and so on. So now with Service Mesh, you're kind of moving all of those custody concerns into another process that always gets deployed with your service, and it sits on the side. It's called Sidecar. It makes polyglot development much easier because you can use whatever language you want for your service, and you don't have to worry about having the service chassis, if I can say the word, always implemented in those multiple languages. So that, I think that's a great case as well. And in terms of Istio, it uses Envoy, which is a sidecar that's independently open sourced by Lyft. And in general, our experience, my personal experience, has been fairly positive introducing it to the network. Your network is fairly simple. There are a couple of things that I'm still waiting to be ironed out and see, and in fact, ThoughtWorks is contributing to the project as well here in North America. And one is, if you want to provide security between in your mesh and outside your mesh with neutral TLS, that requires a little bit of, I guess, manual intervention in terms of uploading your master certificates and certificates into your certificate manager. And that we need to kind of improve over time. And also management of just the configuration of the mesh, who has control to do what, because autonomous. So I would highly recommend it.
Shamak, sorry to interrupt you. A couple of people are reporting in the chat that it's been a bit hard to hear you. If you can perhaps speak closer to the mic, that might help.
Sure, and I might actually change my headphone in a minute. Okay, I will try to speak more loudly and slowly.
Okay, well, it sounds better to me now, but let's see what people say in the chat. But it sounds a lot better. Thank you.
Okay, perfect.
Okay, so Sudarshan, before we move on to the next one, there are a couple of questions related to Timescale DB and actually comparing Timescale DB to InfluxDB and MemSQL. So how do they compare, and what features of Timescale DB would make it more compelling? So could you talk a little bit about that before moving to the next one?
Yeah, sure, Alexei. So yeah, I mean, InfluxDB is an industry stalwart, right? And there are no doubts that it's actually a very good time series database. In fact, in this particular edition of the Radar, we actually moved InfluxDB to trial, given that we've used it in production so often, and it really does a good job. I think as time series databases go, InfluxDB is definitely the most popular choice at this point. And I would say Timescale DB is still a relatively new entrant. In terms of sheer performance, I fully expect that Timescale DB will be able to match InfluxDB. If not today, then in time. I think the real question is perhaps the future direction and the evolution of those two databases. They've basically made two different bets, right? Like Timescale DB's bet is, building around Postgres. You leverage the full Postgres ecosystem and you benefit from SQL and joins and all the stuff. Like SQL is a big deal, right? Like last few years, we have seen increasingly NoSQL databases increasingly enhance their query language to behave like SQL, because people are now realizing, they gave up a lot when they moved away from relational database and they want the power of SQL. But InfluxDB is taking a slightly different bet. It's taking a bet, it introduced recently almost a data processing language. It's almost like a domain-specific language called Flux. And it's it's a bet where, you can express almost what you want to do with your data. It's both in terms of querying as well as processing. And then the influx engine will push the query down or the processing down to the actual data nodes and then process and return the results. And they are hoping that Flux becomes a broader standard, right? And so it's almost two different industry directions. One sort of trusting that, SQL and joins and relational stores add a lot of value, and Influx sort of going a slightly different route. I won't hazard a guess which will win out. I think they both will have their role to play. But I do feel Timescale DB has perhaps some attraction for use cases where, the whole relational ecosystem, secondary indices, flexible querying, all those sort of things come into its own.
Okay, thank you very much. And what else did you see in this new edition of the Radar? And
yeah, so I'd like to briefly talk about Apache Beam. It is an entrant which has been there in past radars, but this time we moved it to trial. We had enough projects in production and we felt it was a good candidate. So as we all know, like for the last few years, industry has largely shifted from batch to streaming, and Apache Beam has this really wonderful model to express streaming, it's largely it's influenced by the Google's data flow model. In fact, originally came from the Google's data flow model, but it's really a wonderful way of expressing the concepts around streaming. And Apache Beam, what it does is it tries to, its core premises, it's three things, right? It's this model to express concepts around batch and streaming. It's a set of SDKs for constructing pipelines using this model. And it has a bunch of runners, which are then used to execute the pipelines. Apache Beam basically does two things. It says, I'm going to provide this wonderful model for streaming for you to code in. And you know what? I'm going to go to build the runners. I'm instead going to build adapters to pick existing streaming runners. Like, for example, you have adapters to Spark, to Flink, to Apache Samza, Apache Apex, even Google Data Flow, actually. So in a sense, it's almost like an abstraction on top of all these various processing engines. And the premise is, if you're bewildered by the constant, new processing engine, just when you feel you've sorted out Spark and then you get Flink, and just when you feel you've sorted out Flink, you get an Apache Samza. Like if you are bewildered by all that, perhaps Apache Beam is a good way to go, because that focuses more on the streaming domain rather than worrying about the nitty-gritties of the actual runners and stuff. Another interesting thing about Apache Beam is that how does it do that? Like, because it tries to build this streaming domain, but then it has all these runners, then how does it keep all the APIs in sync with all the vendors? Is it the lowest common denominator problem, that sort of thing? But what it does is it takes a slightly different tag. Because it's focusing on the streaming domain, they strike a delicate balance between pulling innovations from all these runners into the Beam model, and then working with the community to influence the roadmap of these runners as well, so that these runners continue to remain relevant and tightly integrated into the model itself.
Okay, thank you. Sounds very, very exciting. So maybe it's time to share one of the themes, right? We're going to share two themes on this webinar. Sudarshan, what is the first one?
Yeah, so this is our first trend for first theme for today, right? Like themes, for those who don't know, are summarizations of some of the things around current radars blips that we are seeing as cohesive. But they are also a summarization of some of the conversations leading up to those blips. So this particular theme, we are calling it shifting shapes of data. And really what we are trying to articulate here is we are in the middle of multiple trends relating to data storage and processing. These trends are still playing out. We still don't know whether they are, what's winning out and what's the final state. But the fact is we are in the middle of these trends, and therefore the shape of data is shifting. That's sort of the theme here. And to call out some of these actual trends, right, to add meat to this, is one, of course, we just talked about the time series database, rise of time series databases. I occasionally I read a meme in, in the internet which says, is all data time series data? Arguably, you could think of it that way. It's interesting to see how that will proceed. Will it actually make your modeling superior? Will it actually help genuinely in some of our projects? That's yet to be seen, but definitely rise of time series data is one of those themes. Another is, and while there are no blips in this particular radar, there have been multiple blips in the last few radars, renewed focus on scalable relational databases. Like you saw the rise of NoSQL, and then now we are seeing things like Spanner and Cockroach DB, which promise scale without sacrificing attributes of relational data stores like SQL and consistency and stuff like that. Again, in the last few radars, we talked about Kafka and the ecosystem surrounding it, which suddenly introduces the possibility of treating event streams as the stores of truth. So, it's sort of blurring the line between events and state. With recent, things like KSQL, for example, it's blurring it even more. And one more theme here is, of course, what we just talked about previously around the resurgence of SQL itself. We see a lot of NoSQL stores adding SQL-like capabilities to their query languages. It's sort of recognizing that, applications are feeling very constrained with some of the query languages, and they want the flexibility of being able to join across multiple partitions and so on and so forth. And that's the SQL making a comeback. So it's a very evolving landscape and multiple trends under play. I guess it puts a little bit of a onus on us to sort of continue to understand and figure out where the trade-offs are and what the challenges are and stuff like that.
Oh, that's great. That's great. Yeah, it does seem like a very dynamic landscape and a plethora of new techniques and new things coming in. Well, it's on us to know when to apply that. So I wonder if this changing landscape, it can become very tricky, right? And lead people to misuse techniques that are very appropriate for one context. When you bring that to another one, you just misuse that, and you create a problem. Are there any examples of these, maybe, Sudarshan, or?
Yeah, absolutely. There are examples, right? Like, for example, we talked about KSQL and Kafka and such. And one of the things we were debating, while this didn't make it as a blip because we are waiting to see some more data and evidence to support this, is that we can perhaps sometimes take this notion of event streams as a source of truth too far, and then treat it as a database, and then KSQL as if you were running SQL on top of a database, and then put in a lot of logic there. And before you know it, you've lost all the characteristics of what makes code maintainable and testable and modularity and all those sort of things. I think it's very early days to call it out as a concrete thing to hold on, but definitely these are the sort of examples of, you see a new thing and you apply some of what you're comfortable with, SQL on database and KSQL on event streams, but you know what, the two are totally different paradigms, and we need to evolve new techniques or new good practices, I suppose, rather than just borrowing from history. Great,
thanks. I heard there were good discussions around using change data captures in bad ways as well for integration and things like that. Is that one of the blip that we have?
Yeah, absolutely. And I think, I expect we'll probably see that shortly, I believe. that's one of the blips we might have later on.
Good. So maybe we can go to the next slide and talk a little bit about that.
All right, there we are. Sorry, yes. Yes. So yeah, change data capture. It's a very popular technique. I think in the past radars, we have talked about a couple of tools like Debezium in the space. It has multiple uses. I think one of the more popular ones, if you're refactoring your monolith into microservices, then you use change data capture. It's a brilliant technique to sort of shovel data around to the evolving, emerging microservices from the monolith. And there are many other use cases like cache updates and stuff. But I think the thing we want to call out here, and that's why it's a technique on hold, is there is a slippery slope here. And that is because the way CDC works is, at least a CDC like Debezium, which look at your transaction log in the database and creates events, is these events often model a table, right? Like, so they push changes to a table into a topic. Now, essentially what happens if a consumer uses it is they are now coupled to your data model. So it's almost like treating your data model as an API. What's supposed to be an implementation detail has now been surfaced to other consumers. It's okay if you're within the bounded context and where you understand the implementation detail and you're coupled to it anyway. But the further away from the bounded context you are, what if it's a different system, for example, then you're definitely, it's I guess a different way of integrating via the database pattern that we've called on hold in the distant past. And it's repeating some of those mistakes here. We're starting to see some of this, and that's why we wanted to call it out and put it on hold. A good way to articulate it again is a previous blip we talked about. We talked about domain scoped events, which is saying, recognize who your events consumers are and what assumptions you can make, and make sure your events structure represents that. And directly using CDC and integrating between microservices feels like it's definitely stretching it too far and definitely violating encapsulation here. So it's a slippery slope. Be cautious. That's the message.
That's great. Thanks so much. And very solid advice, actually. So that's wonderful. Now moving a little bit away from data architectures. So Jean-Marc, I hear there's also blips related to serverless, native and cloud events. Is that right?
Yes. So just one quick question. How is my sound right now? I changed my audio input. Is that any better?
It's much better for me now.
Okay.
So
perfect. Awesome. Okay, so these two, again, two of my favorite blips. They're kind of related, so I'm going to try to do a good job, much better. Some people are writing that the audio is better. So Knative. Serverless architecture, or serverless, kind of is such an overloaded term. And it really defines a spectrum of architectural styles. And you can think about, on one end of this spectrum, you've got the backend as a service, or BaaS implementation of the serverless, which was popularized by Firebase, which you basically, expose an endpoint that gives you access to the backend database, and you don't write any other code around it. That's one end. And then the other end of the spectrum, we talk about serverless as implementation of the function as a service, and architecture that allows you to basically deploy functions and run functions that react to an event. So they get evoked and executed when an event happens, and maybe the event is from a database, from a timer, or from an event queue. And basically it scales down to 0. So there would be no server consumptions and no configuration and management of the server. And Amazon Lambda, AWS Lambdas, Azure Functions, and Google Cloud Functions are implementations of that for different cloud providers. So Knative is an open source and Kubernetes-based platform that essentially lets you run function as a service workloads as containers. In fact, just last week here in San Francisco at Google Next, they announced a new managed version of Knative called Cloud Run that they kind of manage for you. And it basically lets you run serverless containers. And sometimes, the purists might argue this is not fully serverless because you still have containers, but it sits somewhere on that spectrum. It allows you to react to HTTP calls to scale up, and basically scale down to 0 when there is nobody calling the function or there's no events to react to. And it takes care of networking and high level of abstractions to kind of listen to event streams. There are a few things that I'm personally really excited about Knative. First and foremost, we've been in a very proprietary world in terms of implementations of PaaS hosted by different cloud providers. And this makes that a cloud, this is an open source kind of SDK or platform that makes the functions that you write to run on any cloud provider that supports Knative. So it removes that dependency to the actual provider. It also implements a couple of kind of open source standards or conventions that are being developed right now around serverless by CNCF, standard serverless working group. There's a white paper that you can find on CNCF GitHub repo, which describes what serverless computing is, and it complies with that. It also provides interoperability between different implementations of the cloud providers in terms of the eventing framework, and that's the next flip. It implements the CNCF cloud events specification. I'll talk about that in a minute. And most importantly, there's another problem that comes with serverless. When you have an environment that, you have long-running containers, let's say you have Kubernetes running with your application deployed as, Docker containers, and these are long-running containers. And then you have a bunch of serverless workloads in the middle of that as well. And you want some sort of a harmonized way of consistent way, like the service issue that we mentioned, to still have some of those cross-cutting concerns consistently applied or implemented across your serverless and your normal containers, such as you still want observability, you still want to see the traces that are going in, you still want to have security implementation. And what Knative enables is that harmonized environment. So actually you can use Kubernetes, Istio, Knative all together to have an harmonized operational environment for both server full, I don't know what's the opposite of serverless, and your serverless workloads in one environment. And I think that's really really exciting. It supports a lot of different kind of eventing providers underneath. It supports AWS SNS or GCP PubSub, Kafka, Apache Camel, and we hope to expect that list to grow. Quickly, cloud events is something that I kind of mentioned in the context of Knative. It's an open source kind of standardization, is a convention and standardization around the eventing frameworks and the triggering mechanisms for the functions of the service. And that's an area that people have been complaining about or concerned about. One of the main first concerns of, okay, we're going to run and implement a serverless or function as a service architecture, and it's going to be tightly coupled to whatever cloud provider this is going to be hosted on, because every cloud provider has its own proprietary way of triggering and responding and capturing kind of events. And cloud events is, again, another attempt. It's one of those projects supported by CNCF as sandbox projects, and it's in early days, to standardize that framework. So then you can run your functions on any cloud provider that you want. And some might argue, that surface area is fairly limited. So, the cost of moving from one cloud to another, just from the functions point of view, it's not that much. But I think we're moving towards the right direction in terms of standardizing that. And then if you look at their specification, there are different aspects of the eventing system that they're trying to standardize, anything from the structure of your events, the metadata that goes to that, and how you react to those events. It has binding to different layers. So it's transport agnostic, but it has kind of different bindings for running your eventing over HTTP or MQTT if you have an IoT devices, and kind of standardize that. And I would actually personally use that even for non-serverless functions. Event streaming is a popular way of communicating between services, even though they're not functions. And I would use their structure for interoperability.
That's great, thanks. And one question we have in the chat. So Bhaskar is asking, how does Knative play with Google Anthos?
So Google Anthos was, again, announced last week at Google Next. So it's part of the ecosystem. So Anthos is an extension to Kubernetes, so that you can run your workloads in hybrid environments, whether it's on cloud and on-prem or multiple cloud providers. So that's an attempt to do that, and part of that ecosystem would allow running Istio or Knative, anything that is Kubernetes compatible on top of it. That's my assumption. I haven't, since last announcements, I haven't had a chance to actually play with Anthos, but that would be kind of my assumption, that Anthos would be, wherever you ran your Kubernetes workloads is more or less the same as you would run it on Anthos. Anthos gives you other mechanisms that you need to have this across multiple clusters and across different cloud providers.
Okay. And there's also a question compared to K8s. So what considerations before migrating from K8s to Knative? Anything to—
Right. So it's not so much of a direct migration from Kubernetes to Knative. I would say if your workloads include serverless, if you're purely trying to be function as a service, running functions as a service, then I would say you would introduce Knative to your environment. But very likely, you will have a mix of those. You will have some functions as a service, some long-running containers. So you would have, Kubernetes as a foundation and Knative kind of on top of that. So that would be my answer.
Great. Thank you so much. Okay, so we're coming to the end actually. So Darshan, do you have any final blip you want to share and talk about?
Yeah, sure. The blip I picked was Micronaut, and Micronaut I picked it because it's quite an interesting framework. It's a Java-based framework for microservices. Now, the reason I found it interesting is because the creators of Micronaut have optimized it for low memory footprint and fast startup. Not exactly the sort of things, if you're in the Java ecosystem, that you normally focus on. They basically are they looked at the existing frameworks like Spring Boot or Microprofile, etc., and did some analysis around what really is fundamentally preventing us from starting up much faster. And one of the things they came up with is that, if you look at Spring Boot, it's really easy to use, but a lot of what makes it work is all the annotations and the dependency injection. You just have to say an add controller and all the beans just get injected in. And so much of the behavior is just based on all this runtime reflection, which is when you start up, you scan your entire jar, you figure out all your beans, you build up in-memory data structures, do your dependency injection, so on and so forth. And this, in fact, has two implications. One is, of course, it reduces your startup time, but it also increases memory consumption because you have got all these in-memory data structures. And this is, in fact, proportional to the size of your code base. So the bigger your code base, the more memory which gets consumed. So what they did was basically they tried to shift all of this to compile time. They used Java's ahead-of-time compilation features, in this case, annotation processing, to essentially do their dependency injection at compile time. They basically, pass through the code, figure out what are the dependencies, and create code in turn to sort of do the dependency injection. They managed to get down to almost like a few hundred millisecond startup time with a memory footprint of almost 10 MB for a Hello World app. That's pretty cool. And I was pretty impressed with that stat. What's really exciting me though is the potential, particularly if you put Micronaut together with GraalVM. GraalVM is Oracle's VM for everything sort of thing, where one of the things amongst everything else is it compiles down to native code and essentially takes some of the JIT features and builds it into the app itself and does ahead of time compilation. Now, if this is still experimental, both GraalVM's experimental as well as its support for Micronaut, but so what they've actually managed to do is get Micronaut starting up in like 50 milliseconds. Like, that's incredible. But when you use the GraalVM support and compile down to native. So this is all very exciting, and I think a great space to watch out, particularly because it starts to open up a range of behaviors. Like, think of out of container tests, which used to take many seconds and you wouldn't have many of them. But now if they start to take sub 100 milliseconds, you can suddenly start to have a lot of out of container tests, and suddenly things become more tractable, which historically weren't. And of course, this now starts to make Java attractive for IoT and serverless startup, cold start and stuff like that. So generally, a very interesting framework worth keeping an eye on.
Thank you so much. And Jean-Marc, how about your final pick to share with us?
I chose an old one, but I think the movement was noticeable enough to kind of talk about it. Terraform. So Terraform by HashiCorp, people have used it. It's a framework for writing your infrastructure configuration as code. It's a multi-cloud kind of, or the cloud agnostic framework. It creates high-level abstractions to be able to configure your infrastructure on AWS or Azure or GCP. I think the reason I chose this one since 2 years ago, when we put Terraform on our on our radar, is that we've seen continuous improvement and development. We've seen amazing kind of community involvement for taking the features on board, and it's essentially become our sensible default for implementing infrastructure as code. And it's worth mentioning this is because, if you're moving to, for instance, AWS and you're starting building your platform, often, let's say CloudFormation is a pretty sensible place to start. But what we've noticed is that as your infrastructure grows, that becomes kind of very hairy and unmanageable. So Terraform, I think, is a common. It's a good tool kind of to use. We're using it. We've been successfully using it on a lot of our projects, and we have actually a counterpart to this, which is on hold, handwriting or hand cracking your own kind of CloudFormation scripts. And CloudFormation is just a declarative way of AWS proprietary, I guess, declarative language for AWS infrastructure to be set up. And what we found with that is that as I mentioned, as the frame kind of your environment grows, some of the limitations of that, like limited parameter definition usage, poor readability of your configurations, no type checking, no imperative constructs to have kind of more readable, reusable modules with your kind of infrastructure as code configurations, that Terraform and also a whole bunch of other tools and other frameworks on our radar address. But I think Terraform is a good place. And leading, I guess, to that, the theme that we noticed that there were a lot of discussions around kind of Terraform and, for example, there were discussions around automated testing of infrastructure, TerraTest, which is a Golang. I will type the name in the chat in a minute as well, which is a Golang-based library that allows you to automate your Terraform scripts, automatically test your Terraform scripts. So you can run your tests, they set up your servers, they set up your networks and firewalls and deploy applications. And like any good test, after running the test, they clean up everything again. And it's a great way of doing end-to-end infrastructure provisioning tests in real environments. The Go CD pipeline that I mentioned earlier, which is a CD pipeline, open source CD pipeline implementation by ThoughtWorks, also introduced Terraform as a provider, which essentially means you can use Terraform to configure your Go CD pipelines itself. So we've got a theme around that you can read on when the radar comes out. I think we're seeing a lot of maturity in cloud-based provisioning, particularly using Terraform and TerraGrunt, which is another tool already on the radar, an opinionated, I guess, way of writing Terraform and abstractions around it. So it's definitely a place to watch out.
Oh, great. Thank you so much. Yeah, we definitely hear many teams praising Terraform and having using it heavily. So a couple of questions came up related to Terraform. One is any thoughts on Pulumi as an alternative?
Yeah, so we were quite excited about Pulumi when it came out because this world between oh, I'm going to do configurations as some sort of a declarative script versus I'm going to use a full-blown programming language to imperatively configure my environment. And we see kind of this swing between the two. And Pulumi fits on the imperative language. So fully using programming language to configure your environments. And I think that's been on assess, I think, and it's still on assess. I haven't personally come across many implementations of that. I think we were excited because it gives you a very powerful tool to configure your environments, but with power also comes, the level of knowledge and the responsibility that you need to have, especially maybe a more steep learning curve for some of the infrastructure folks. So it is a tool, again, in that tool chain. I wouldn't directly compare it to Terraform. Absolutely, it would be, you would probably use it instead of Terraform, and for some of the maybe configurations, aspects of your systems, it sits in that ecosystem. But again, I don't think we have enough data points to say, use Pulumi versus Terraform, because maybe there are parts of your configuration you can start playing out with Pulumi to see how it works for you, given the skills that you have in your organization, and complement Terraform with it to get a sense for it. Well, I wouldn't use it as a direct alternative just for the level of maturity and adoption in the industry and the support that you can get from the community on Terraform versus Pulumi. But it's definitely an interesting kind of complement to the ecosystem.
That's great, thanks. And maybe we have time for one final question. There's also a question asking about Terraform, the use of Terraform on premises, and the question specifically on VMware, vSphere, but how does it change using Terraform away from the cloud? Let's put it that way, and any major changes or major considerations? Or
yeah, I'm going to pass on that. I don't have a lot of data points on that one to share at this point. I'm happy for you to reach out to me. I have to consult my teams. I know that we are using kind of infrastructure like Terraform on for some of the cloud implementation on premise, but I'm not particularly familiar with the gotchas or the challenges that you might have with particularly vSphere. So I'd have to pass on that, but I'm going to do my homework, so you can reach me at JoMacD on Twitter, and I'm happy to get that information from our teams and share.
Okay, that's wonderful. Thank you very much. And well, I think we're at the top of the hour, so we're going to need to close. But thank you very much, Sudarshan and Zhamak, for being with us, and thank you all for joining. I had lots of fun, so I hope you enjoyed this too. And stay tuned for the launch of the 20th edition of the Tech Radar. Thank you very much.